Hello and welcome to another Algebra 1 video tutorial. In lesson 12.8 we will be factoring and rational expressions. Our goal will be to apply factoring to operations with and simplifications of rational expressions. So remember what a rational expression is. It's a quotient of two polynomials. So the first example here, let's write the quantity 6x squared minus x minus 2 over the quantity 3x squared plus x minus 2 in lowest terms. So we don't want any factors in common. We want to cancel those out. So what we have to do is we have to use factoring, and you've gotten hopefully pretty handy in this chapter at factoring. So the top, the numerator, will factor into, well, we could try 6x and 1x, or we can try 2x and 3x. Let's try 2x and 3x. Okay, now we need to get negative 2 and need to multiply to be negative 2, so that's got to be 1 and negative 2 or vice versa, or it changes the positions of them, and then they add up to a negative 1. Well, I know if I can get 2 times 2 to be 4, and then 1 times 3 is 3, and one of them negative, and the larger one negative. So I need a minus 2 here to make 2x times minus 2, that make that a negative 4x, and then I need plus 1 here to make this middle terms 3x, and then they add up to negative 1x. Okay, so that factors the numerator. Now we need to factor the denominator. Now we like 3x squared because the only way to get that is 1x and 3x, they multiply to be 3x squared. Now same thing, we need to multiply to be negative 2, but now they add up to a positive 1 here. So when we do this and there's we want lowest terms, chances are there's a common factor will cancel out. So it's either going to be, well, it has to be, the only one that's going to be in common would be a minus 2. Now will that work if this is x plus 1? So it'll be x times a minus 2, so that's minus 2x. 1 times 3x is 3x, so 3x and minus 2x make our 1x. So that factors. Now what we can do is take a common factor out, and those go to 1s, and we're left with the quantity 2x plus 1 over the quantity x plus 1, and that is this rational expression in lowest terms because they don't have any more common factors. You can't cross out the x's and the 1s because they don't all have a 2, so be careful what you cancel out. That's not possible. You can test numbers for x to show that that doesn't work. Now there's also some restrictions on our original, so the domain's going to change, so there's some restrictions on what x can't be. We don't want the denominator to be 0, so we either assume it's not 0, or we can say what x values will make it 0. So we got to say x cannot equal, well, we got this factored, which makes it easy to figure out the zeros where this is 0. Negative 1, right, because negative 1 plus 1, and this one would be 2/3. So x can't be negative 1 or 2/3. Now on this last fraction, if this is all you see, we know x can't be negative 1, but we would forget about the original that x can't be 2/3 either. Okay, so these are just the restrictions. This is the main answer. This is just a little additional information about what x can't be to make this, to do the domain, which we did quite a few chapters ago. Alright, number 2, let's simplify the expression 2x to the 4th minus 6x cubed minus 20x squared plus 48x all over 4x to the 4th minus 4x cubed minus 88x squared plus 160x. That looks complicated, and it is. Now what can we do to simplify this? Well, we're getting some common factors, but we got to the 4th power. We got a 4th degree over a 4th degree. What's this going to look like? Well, let's take the GCF out first. It appears there's a 2x in everything there. So let's factor out a 2x. And what's left? Well, we'd be left with x cubed minus 3x squared minus 10x plus 24. Okay, in the denominator, it looks like we could take a 4x out, so we could factor out a 4x, and what's left would be x cubed minus x squared minus 22x plus 40. Now, we don't really know how to factor x cubes, so we're going to need some more help here. Well, the help will be our graphing calculator. So what I would do is graph the numerator and graph the denominator. So put this in y1, put this in y2, or just graph them totally separate. So the numerator, so this right here is the numerator graphed. Okay, so what I'm looking for here are the x-intercepts, because that will help us factor. Now we already know one of the x-intercept is 0, right? Because if this x is 0, it makes that whole thing 0. So we know right there is 0, and then there are 3 more, hence the cubic. So we're looking at, looks like -3. We got the 0 there. This one's 2, and let's see if that's 2, 3, 4. Okay, so we need these other factors. Alright, so we'd have 2x. Now, x, and then we have a minus and -3, so that'd be x plus 3, because it's an x-intercept, so -3 would make this quantity 0, and that makes everything 0. Okay, then we also have the 0, which we got with the 2x. Then we have a 2, so it'd be times the quantity x minus 2, and then we have an x-intercept at 4, so it'd be times the quantity x minus 4. Now we do the same thing with the denominator. So this graph down here is the denominator. Now we already know that one of them was 0, that guy right there. So it looks like 1, 2, 3, 4, 5 at -5, at 2, 3, and 4. Okay, so this will factor down to 4x, which we knew. Then we have x minus -5, so it'll be x plus 5. Then we have x minus 2. And we have x minus 4. Okay, so see how I use the graph, the x-intercept of the graphs, to help me factor this expression. Besides, what I did first is take the GCF out. Now, what cancels? Well, we could take a 2 and a 4 and reduce it to 1/2. We could cancel out a common x there, make those 1s. I could take the quantity x minus 2's out, make those 1s, and the x minus 4's, I can make those 1s. So what's left is the quantity x plus 3 over, now I have a 2 and times the quantity x plus 5. Or I could also say this is x, the quantity x plus 3 over the quantity 2x plus 10. Either one would work. Now once again, what can x not be? Because from the original expression to our lowest terms expression, we know that x can't be -5 down here, but what else can it not be? Well, x can't be 0, because that would make that 0. Basically, x can't be these x-intercepts here. So x can't be 0, it can't be -5, it can't be 2, and x can't be 4. But only in this last one here, which would be our final answer, x can't be -5. But from our original expression, our domain would have had to say x can't be 0, -5, 2, and 4. Alright, write 2 over x minus 3 over y as a single rational expression. Now, I would like you to first think about, maybe pause the video, see if you can simplify this on your own, because really it's not that difficult. But most people at first glance will get this wrong. So think about if it was 2/3 minus 3/5. You would never, I would hope you would never say this is 2 minus 3 and 3 minus 5. Oh, so this is equal to 1/2. I hope you would not say that, and I hope you would not apply that to this, because why can't you do that? Well, you don't have a common denominator. So don't do that. So I would hope if you had once again, so let me try that again, 2/3 minus 3/5, so I'm just saying x is 3, y is 5, you would need to get a common denominator, and the common denominator would be 15, so I would need to multiply this denominator and numerator by 5, and over here I need to multiply it by 3 and by 3, so that's like multiplying by 1. So this becomes 10/15 minus 9/15 would be equal to 1/15, which is a long ways away from 1/2. So that same idea applies here. We need a common denominator because x and y are not the same denominator. So the same rule applies. We're just going to get a common denominator, 2 over x minus 3 over y. What can you do? Well, the common denominator would be xy, so we need a y here and a y there. That's like multiplying by 1. And we need an x here and an x here, and that's like multiplying by 1. So we end up with 2y minus 3x over the common denominator of xy, and then these are unlike terms, so there would be our answer. And once again, we assume x and y can't be 0 because we can't have division by 0. So x can't be 0 and y can't be 0. But no different than what you have learned before with subtracting fractions. Alright, this one's a little more complicated, but the same idea applies. So let's write 3 over x squared plus the quantity 4 plus x over the quantity x squared minus 1 as a single rational expression. So we're going to use factoring to help us group this into one rational expression. So let's factor that. So it's going to be 3 over. Now the factor at the bottom, they only have an x in common, so it's going to be x times the quantity x plus 1. That would be factored there. And 4 plus x over, this is a difference of squares, so that's going to be the quantity x plus 1 times the quantity x minus 1. I hope you would see that as quick as I did if you've had enough practice with that by now. Alright, now what is the common denominator? Well, we have an x and a quantity x plus 1. This one has a quantity x plus 1, but a quantity x minus 1 as well. So this one needs an x with it. So we have to multiply by x. But what's this other one needs with it is a quantity x minus 1. Okay, and I would probably, if I had room, I would write that maybe in the back here to make it look a little better, to make it look exactly the same. So I need a quantity x minus 1 so that I'm multiplying by 1 here. Okay, so now I have a common denominator. So I'm going to have 3x minus 3 plus 4x plus x squared all over, so I just added the numerators of these because I have a common denominator, which would be x times the quantity x plus 1 times the quantity x minus 1, and then I would simplify that as much as I can. Let's put it in standard form. I have an x squared, and I have a 4x and a 3x, so that'd be a 7x, and I have a minus 3 over x times the quantity x plus 1 times the quantity x minus 1. Now I can expand the denominator and write it like that if I want. So I could say, or this is going to be x squared plus 7x minus 3 over. Now if I multiply these two together down here, that's a difference of squares, so that's going to be just what it was originally, x squared minus 1, x squared minus 1, and then distribute the x. So this is going to be x cubed minus x, and there would be my final answer, or this is acceptable as well. And we just have to denote x cannot be 0, -1, or +1 on either of these answers. Okay, your assignment will be 12-8, page 765, numbers 2 through 24 evens. Thanks for tuning in, and we'll see you next time.